Hi, I'm Ryan Palermo, and I'm a Buki Marketing Manager here to be your host for today's discussion, looking at comparing benchtop NIR and inline NIR. Today I'm joined by Jason Corbier. Hi, Jason. Jason is one of our NIR specialists at Buki, and he has been helping match up our customers with a good QC solution for their lab, or as we'll dig into today, the production floor.
Thanks, Ryan. Appreciate the introduction. And I'm really going to do my best to give a broad overview of the technology today for people that have really never used it in the past. And so in general, I've worked with professionals in the food, chemical, pharmaceutical, and other industries to help identify QC solutions that meet their needs and ultimately their organization's goals.
Excellent. Well, before we get into more of an apples to apples comparison of this benchtop and NIR, can you give us a general idea of why NIR is a good QC solution across that broad array of industries you just mentioned?
Sure, yeah, absolutely. So QC labs are often home to equipment like HPLC, LCMS, GCMS, titration, balances, extractors, steam distillation systems, and of course more. And these traditional analytical methods have been really the gold standards for QC professionals from the 20th century into the 21st century. And while much of that technology has seen really decent upgrades over that time, some limitations remain. And these limitations can be addressed by adding NIR technology as a supplement to their existing processes.
Okay, so what are those major problems or limitations that the QC labs are facing today?
The way I see it, the biggest problems that they are dealing with are primarily related to labor, safety, and feedback loops of information.
Okay, so let's unpack those. Let's just start with labor.
Sure. So more than ever today, especially since the onset of COVID, labs are having to do more with fewer people. Have you ever tried to hire anyone recently?
Yeah, it's a tough job, and there are more jobs open than people to fill them, it seems.
Exactly. And on the other side of the coin, we're seeing more being demanded of the smaller groups that remain at those organizations due to budget constraints and shrinking profit margins due to factors like inflation. So efficient methods are almost non-negotiable for some companies that can't afford to increase their headcount.
So what is the issue with these traditional methods in the context then of this labor and resource shortage?
It really comes down to sample preparation. So for a lot of those traditional methods, samples need to be ground, dissolved, concentrated, or otherwise prepared. And that preparation sucks up a lot of time and resources. And the wet chemistry methods also typically require a more skilled workforce as well.
Right, in that competitive and work environment, it's harder to find those skilled people. So that's tough, right?
Right, it's not easy.
So let's skip ahead now to the problems you alluded to with workplace safety.
Great question. So really, anytime chemical solvents are involved, the workplace risks go up. Certainly, there are ways to mitigate those risks. For example, with extraction and kill-all systems, which Buki manufactures, they have automation and safety sensors that limit user contact with chemicals, and that helps. But you can't really get away from the necessity of solvents for many of those primary methods that we mentioned earlier.
Yeah, for sure. Liquid chromatography, kill-all extraction, solvent's just a necessary evil to get the job done.
With NIR, on the other hand, is a non-destructive technique, so no solvents are required. And there's really no sample preparation either.
Although, right, to be fair, there are some methods that work better if you grind up a sample first. Is that right?
Way to call me out, Ryan. Thank you. But in all seriousness, that is true. And we do have some applications that are more precise when ground samples are used. But for the most part, especially working with powdered samples, there's really no sample prep at all.
Right. Or liquid samples too, I guess, right? Okay, and then I guess moving away from just solvent use in general is going to help a lot of these corporations meet their green chemistry initiatives.
Exactly. And NIR is certainly a green technique. So reusable sample cups and contact sampling with fiber optic probes or inline sensors make most of these applications zero waste.
I like that.
So do most of our customers.
Let's look at that last category, the problems with traditional wet chemistry methods having a slow feedback loop.
Yeah, so the main issue is low frequency data collection and long feedback loops. So even the fastest traditional wet chemistry methods may take north of 10 minutes.
Yeah, and I guess a lot can happen, especially in production environments, between those 10-minute or more data points. But how about benchtop NIR as an example? How long should we expect measurements to take using benchtop NIR?
Good question. So assuming no sample prep, just to run the sample, measurements can typically be collected in about 30 seconds or less. And not only that, but you also get to capture multiple properties at once. So this is an additional efficiency that customers also enjoy. So for example, they can measure fat, protein, ash, moisture, and color all at the same time. And these are only just a handful of the dozens of material properties that you can measure simultaneously via NIR.
And what are our customers doing then when they turn around that data? What are they using it for?
So assuming you're using a good benchtop NIR, plant managers and their staff can do things like check the quality of incoming ingredients right in the warehouse. They can also do endpoint determinations for mixing, drying, and other processes. And the idea is to flag deviations and make decisions that will save the organization from having to do batch rework or putting that batch in the dumpster.
Okay, so when you're comparing benchtop NIR to inline really just cuts that feedback loop down even more, correct?
Exactly. So to shift gears, I'm going to use a metaphor. And so it's really the equivalent when you're comparing benchtop to inline measurements of driving down the highway in your car with your eyes closed and opening them once an hour. But in this case, you have superhuman vision like a hawk. You can see for miles. Maybe you can even see outside the visible spectrum like in UV or infrared. But at the end of the day, you still only see once an hour. So this is really where the rubber hits the road, so to speak, with real-time process monitoring. The idea is to keep your eyes open all the time.
I certainly like to do that when I'm driving. All right, so it's pretty safe to say that one of the biggest differences that sets inline NIR apart from the benchtop is that you're, making that feedback loop even shorter, and it's just super convenient, even more convenient than that benchtop NIR is.
Right, yeah, exactly. So process analyzers or inline sensors go, as you would imagine, right in process. And that can mean in hoppers, blenders, mixers, dryers, or hovering over conveyor belts. So to use a food manufacturer as an example, measurements like fat, protein, moisture are collected nearly continuously, giving the operators a real-time visual of what's happening at any stage in their production.
Okay, so let's get back to that original question. How would someone know if they're more suited to do the inline or the benchtop NIR?
It's a good question. And my answer would be that many quality professionals already intuitively know how often they see batch failure in their process, and they also know the costs that are associated with either having to rework that batch or having to dispose of it completely. So the decision for in-process monitoring usually comes down to ROI, or return on investment. So is the lack of access to real-time data costing your organization money? Would having more data either on your raw materials or your manufacturing line enable you to catch or prevent mistakes? And once you know the cost and frequency of errors, it's pretty easy to make a choice. And realistically, for some organizations, the answer is no. There's not enough variation in either their raw materials or process for the investment for an in-process monitor system to be worth it. But what we've seen is that most organizations fall into the group where the ROI argument is the clear winner.
Yeah. And to be fair, again, even with the benchtop systems, you're still getting data very quickly, and you're able to collect that high volume of data that you want to be able to capture those deviations, even if it's not maybe expected to be caused by the process itself. Okay, cool. Let's switch ahead to the quality of the NIR data compared then to the traditional methods. What can we expect there?
That's an important question. And in the case of NIR, both benchtop and inline NIR systems are what we call secondary methods. Okay, and so what that means is that we have to connect the NIR data or spectra to the primary data of the properties that the calibration is going to be measuring, like fat or protein. And at the end of the day, the accuracy may approach, but will likely never really reach the gold standard.
So NIR methods can have similar accuracy, but not reach or be better than the accuracy of the reference method. But what happens when we compare the accuracy or even the precision of the benchtop to the inline systems? Is there a difference there?
So if you're comparing a benchtop NIR to an inline NIR, typically the inline analyzers are going to experience much harsher environments than those benchtop systems. And that can be due to vibration from the process equipment that the online sensor is tethered to. It can be due to process temperature variations and fluctuations. And these can limit the performance of the inline sensors compared to an equivalent benchtop spectrometer, either in the QC lab or on the production floor.
Okay. You mentioned earlier that the NIR inline sensors are collecting data nearly continuously. Is data storage or data processing an issue for people, or something they need to consider?
It can be, Ryan. And so if you think about it, so when you're measuring, in real time, reams of data are produced by these systems, and this data is something that companies will need to plan to utilize. And so any potential issue ultimately can be mitigated by regular backups, but data storage and security should still be a consideration when researching these concepts and implementing them for your company.
All right, now let's get to one of the top questions that I'm sure, receive is, what about the cost that when we compare benchtop versus inline NIR?
Down to brass tacks, yes. The cost is an important question, especially when we compare it to that ROI consideration. And from a capital budget perspective, the startup costs for inline monitoring systems tend to be slightly higher, just because in addition to the actual instrumentation, you're also going to need to consider the engineering costs as well as the process adapters to connect the sensor to as well.
Okay, so you mentioned a process tube or interface. What other installation types can we consider for a near online or inline NIR, I should say?
Yeah, for sure. And so there are a lot of different ways to mount a sensor, which is one of the nice things about the technology. But there are also some considerations that we have to keep in mind. So in the case of something like installing a sensor on we'll say, large diameter pipe with a weld-in flange, production may need to shut down for a short period of time, which is, for some manufacturing facilities, not necessarily an easy feat. Okay. Other customers opt for a bypass option, which instead of putting the NIR sensor directly in process, this option is used when the sample flow is discontinuous or there's no good option for consistent product presentation to the sensor. And finally, conveyor belt mounts are probably the least invasive to the manufacturing process, although the product height on the belt may need to be a consideration. In this case, the sensor is mounted either right above or sometimes to the side of the belt. Okay,
so a lot of different options depending on what kind of production setup people have. I'm guessing that at this point here, some people are really starting to weigh those pros and cons of inline versus benchtop. So can you just give us a description of what maybe the ideal customer might be for an inline NIR sensor?
Yeah, for sure. I think the customers that I've worked with that have seen the most benefit from an in-process system are the ones who have process deviations and recognize that the cost of reworking or tossing a batch pays for the system within the first 1 to 2 years of ownership.
Yeah, and it also saves them the hard conversation with their upper management, right?
Exactly. Right. At the end of the day, we want to make our lives easier by implementing these technologies, not more difficult. And at the end of the day, that real-time insight into these manufacturing processes ultimately will alert these QC professionals to how these process deviations may affect their processes and may otherwise go unnoticed.
I appreciate all this valuable information that you've shared today. It's been a very enlightening conversation, Jason. And for our listeners, if you're interested in learning more about the process of implementing an inline sensor, that will be our next discussion that will be featuring inline NIR. And if you'd like to learn more about Buki NIR solutions, you can go ahead and look at www.buki.com and hit the contact us button if you want to ask a specific question. Thank you so much for joining us and listening. And thank you again, Jason.
Thanks, Ryan.
Bye.